In the previous videos, we finished talking about the network layer. The primary service at the network layer is finding the paths between nodes. The participating nodes were hosts and routers. They were connected via communication channels, which we called links. There are several types of links, such as wired and wireless. The unit used by the link layer is called a frame. The frame encapsulates a datagram from the network level. The data link layer primary objective is to send datagrams to an adjacent node that is physically connected over the link. Let's look at the context that implements a link layer. For this, we will use an analogy from the tourism world. Let's assume a tourist wants to travel from Princeton to Lausanne. In the first segment, he can take a limo from Princeton to JFK Airport, then to get on a plane from JFK to the Geneva Airport, from there to board a train from Geneva to Lausanne. In this case, the tourist is the datagram, and each transportation segment is actually a link. The mode of transportation is the link layer protocol, and the travel agent is the routing algorithm. If we go back to the link layer's world, that datagram that we would send on a path can use several different links, and each of the links may implement different link layer protocols. For example, if it starts from a link that implements Ethernet, it can then jump to a link that implements frame relay, and end on a link that implements a wireless link of 802.11 Wi-Fi. Every link may implement a different link layer protocol. For example, it may or may not implement reliability. Let's look at services that are implemented on the link level. The first services are framing and link access. In terms of framing, every datagram is encapsulated by adding a header and a trailer. Fields are added inside the header, such as medium access control addresses, MAC in short, that define source and destination. In addition, there is added information used for the implementation of additional services. The MAC addresses are different from IP addresses, and later we will understand what the difference is. If we need to manage access to the shared channel, then it will also be one of the link layer's services. In case the link layer requires reliability implementation, then reliability can also be implemented at the link level. If you remember, when we learned about the transport layer, we dug into the theory and discussed 3 ARQ algorithms: stop and wait, selective repeat, and go back N. We can use that same theory to implement reliability at the link level. The question I want you to think about is, why do we need to implement reliability at the link layer and at the transport layer? Another service that can be implemented at the link layer is flow control. We're not going to really talk about flow control in the link chapter, but we've seen flow control examples in the transport layer. Another service is error detection. We have seen the use of error detection in the top layers, the network layer, and the transport layer. At the link layer, we use more sophisticated methods that not only can detect errors, they can also fix them. Link layer may be implemented in 2 methods: half duplex and full duplex. In the case of half duplex, multiple nodes cannot transmit at the same time. An example of a half duplex would be a walkie-talkie. When you push the button, you can talk, but the other side cannot talk during that time. The second mode is full duplex. In the case of full duplex, 2 nodes can transmit at the same time. An example you're probably familiar with is that like a phone call. Both sides can talk simultaneously. Where is the link layer implemented? It is implemented in the network adapter, Network Interface Card, or NIC for short. It can be an Ethernet card, a card that implements 802.11 Wi-Fi, and so on. Every network card implements both link layer as well as physical layer and is attached to the host's system buses. What does the NIC include? Every NIC is a combination of hardware, software, and firmware. Firmware is a program that is flashed inside the NIC for frame processing, and the software is an operating system that runs the device. Let's look at how two NICs transmit a frame. Assume there is a datagram in some source. The same datagram is transferred to the link level, and the NIC encapsulates that datagram inside the frame and adds bits for error detection. If reliability and flow control are implemented, then all required information is updated as well. Then, the frame is transmitted to the other side. The receiving side checks for errors. If reliability and flow control were implemented on the other side, then the reliability and flow control logic is run on the receiving side. Additional services can also be implemented by the link protocol. The NIC extracts the datagram from the frame and transfers it to the network level on the receiving side. In this part, we learned what the role of the link layer is. We learned about the properties and primary services that are implemented at the link level. We have seen where the link layer is implemented. We've seen it's implemented in the NIC. And we look at how a datagram is transferred between two NICs. In the next part, we will take an in-depth look at the link level.